All right, so we're looking at 6A today, and 6A deals with characterizing data. Whoops, hang on a second. My paper must came down. All right, so y'all should be able to see it now. So 6A, characterizing data. So we're going to talk about distributions today and the shape of these curves. But first, we're going to look at those measures of the center again. So first, let's look at a distribution. So y'all, the distribution of a variable refers to the way its values are spread out over all possible values, okay? So let me let one in real quick. So the distribution of a variable refers to the way its values are spread out over all possible values. We can also display a distribution using a table or a graph. So later on in this lecture, I'll show you different graphs of the distributions. But y'all have made a frequency table in homework from in 5. And those frequency tables are a type of a distribution, okay? It shows me how many values of each range that I had on that. So we can use tables or graphs to represent our distributions. So we're going to go look at the measures of a center in a distribution. And I sort of went over these the other day for my support homework for 6A. I gave y'all 3 measures, the mean, median, and mode. So I'm going to go through them again and tell us what those are. So the first one was the mean. And remember, mean just means the average. So you're finding the average of all your data points. So to find that average, you find the sum of all data entries. So it's going to be the sum of all of the data values divided by the total number of data. Okay, so I would add everything up and then divide by how many scores I had. So let's see, if we write that as a formula, we would have our mean equals sum of all values divided by total number of values. Now, here's the thing, the mean, so the mean can be strongly affected by outliers. Oh, I got one of y'all giving me some back noise. All right, so the mean can be strongly affected by outliers. Outliers are values that are way lower or way higher than your normal data tends to be. So let me show you what happens when an outlier affects the mean. So what we're going to do. I can't like get in. I'm on it. All right, y'all, hang on a second. All right, so that should take care of that. So let me go back now. All right, so I'm going to show an example of how an outlier can affect a mean. So suppose I had taken a test 3 times. So my 3 scores I got were a 78, a 92, and an 87. So what I want to do real quick is I'm going to find the average of these 3 tests. So to find that average, we're going to add them 3 scores together and divide by 3. So we're going to have 78. Well, let me turn this on, I guess. All right, so it's on now. 78 plus 92 plus 87. All of that equals, what's that, 257? And then I had 3 tests, so I'm going to divide that by 3 and get my average. So divide that by 3. So my average is 85.666. So that's pretty much an 85.7. So then what happens? I made a 0 on my 4th test. So notice that 0 is a lot lower than my other scores. So we're going to call 0 an outlier. So let's see what happens when I add that 0 to my average. So now to find my average with the outlier, so average with the outlier. We're going to add all 4 scores again. So 78 plus 92 plus 87 plus now I got to add in a 0. That's going to give me 257 still. But now we got 4 scores we got to average. So I added that 0 to my scores. So y'all, let's take that 257 and now divide by 4. When I do that, I get a 64.25. So they give me a 64.25. So now that's what I mean by that outlier had a big effect on my average. I was at a middle B average, and that one outlier score brought me all the way down to a middle D average. So y'all, that's the effects of a 0 on a test. It can bring that average down big time, okay? So now I'd have been happy if my outlier would have been 100 range on the high end, but not happy when it's on the low end, okay? So the second thing we looked at was the median. And the median basically was the middle value in the sorted data. So middle value in the sorted data. The key word is the data has to be sorted from small to big or from big to small before you find that middle, okay? if they're not in a numerical order, then you're not going to be able to find the true middle of that data, okay? Now, the median is not really affected by the outliers. And then y'all remember there's two ways to find that median. If you got an odd number of data points, the median will be the exact middle value. If you had an even number, which I'm going to show you the median with 3 of these, and then I'll do 4 of them. But when you have 4 numbers for your median, you find the average of the 2 innermost data points, okay? So if I was to find my median when I had the 3 scores, 78, 87, and 92, for those 3 scores, my median would have been 87. Because it was odd and that was my middle value. Now let's throw in the 0. That would give me a 0, 72, 78, 87, and a 92. So when I got 4 data values, to find the median, I got to find the average of the 2 middle points. So to do that, you're going to add them together. So 78 plus 87, and then divide by 2 because you're using 2 points. So when I do that, I get an 82.5. So notice the difference. I'm still in the B range with my median. It only pulled it down about, what's that, 4.5 points. But up here on the mean, that outlier brought me down 2 letter grades. The median didn't really change. I'm still in the B range, okay? So that's what we mean, that the median is not affected by the outliers as bad as that mean. And especially if I had more than 3 or 4 points. If I had a lot more points, my median would probably even switch at a smaller percent, okay? All right, y'all, so let's turn this over. And the third was the mode. In mode was basically the data value that occurs the most. It's not really affected by outliers. So not affected by the outliers. Because if I had 3 87s, and that was my mode 87, that 0 is not changing that. It's still going to be those 3 scores more than that 1 score. So it's still going to be the 87. So the mode's not going to be affected at all by those outliers. Now just remember one thing about the mode. If none of the values repeat, then there's no mode. So if no values repeat, then no mode. All right, so let me show you an example, and I'm really going to show you how to do this stuff on the calculator and save us from having to do the mean and median on this, okay? Now, you can't really do the mode on the calculator, but you can do the mean and the median on there. So let me get mine ready to go. So we're going to find the mean, median, and mode. Now, I know we did some of these the other day on that support stuff, but I wanted to show y'all another way to do it on this calculator without you having to try to sort your data and all that fun stuff. So on this example, we found 8 prices of a candy bar at 8 different gas stations. So the average prices of those candy bars was $1.09, $1.29, $1.29, $1.35, $1.39, $1.49, $1.59, and $1.79. So the same candy bar at 8 different gas stations, and these were the prices that each gas station was selling those candy bars for. So the first thing I'm going to show you is how to find the mean on that calculator. And then I'll do it by hand if y'all want me to. So I'm going to clear everything off. So the first thing, I got to put my data into the calculator. So to put my data into the calculator, there's a stat button right here where my finger's at. Under the DEL, which is the delete button, you'll see a button that says stat. Push the stat button. It's automatically going to be highlighted on edit right there. It's going to say edit with the 1 highlighted. Well, that's what we're wanting to do. We're wanting to edit this and put our values in. So hit enter. So mine brings up L1, but you can switch this and put it in any of these L's you want to. L1, L2, L3. Now let me show you how to clear it. So say you had some numbers in it already and you want to clear that. You're going to go all the way up here where the L1 is, hit clear. And then when you come back down, it's going to clear the row for you. So that's how you clear out a row of numbers, okay? So y'all, we're going to put our numbers into the calculator. So for each one of these prices I gave you, I'm going to put it in and then hit enter, and it's going to make me a column of numbers. So I had $1.09, so I put in 109, hit enter. And if you notice on the bottom here, it tells you I'm now putting in the second number. That's what the 2 in parentheses is. So my second number was 129, so 1.29, enter. My third number, 129, enter. My fourth number, 135, enter. 139, enter. 149, enter. 159, enter. And 179, enter. So I hit enter. All 8 of my numbers are now into that first column, L1. So now the calculator has my data. So now I'm going to quit that screen and get off of it by hitting the second button and the button right next to it that says mode. That's going to bring me back to my home screen. So here's the thing. We now have our data into this calculator. Now we want to tell it to do the mode. The mean first. We're going to do the mean first. So to find the mean operation, you hit second stat button. So the blue button and then the stat button will bring up what I got on my screen. L1, L2, L3, L4, L5 in that row. And then you see OPS, which is operations, and then math, which is the math operations. We're going to go to the math menu. But y'all notice one thing. When I ask you where am I going to get L1 at later, it's sitting right there. All right, so let's arrow over, highlight ops, and then go on over and highlight math. If you'll notice in the math column, the third thing is the mean. The fourth thing is the median. So since I want the mean first, I'm going to arrow down and highlight the mean number 3 and hit enter. At that point, it brings the mean onto the home screen. So now you got to tell the calculator what you want it to find the mean of. And y'all, that's where I put my data in L1. So I need to tell it I want to find that mean of L1. So we got to go grab that L1 that I just showed you. So to do that, you're going to hit second again and stat. L1 is highlighted. If you use a different list like L2 or L3, you got to arrow down and highlight that one for your data. So my data was in L1, so I'm going to hit enter. So now on my home screen, it says, hey, you're going to find the mean of that list one we put in there. So we hit enter, and my mean price is $1.41. Now we'll find a median and then we'll do that stuff by hand if y'all want. So remember, I got to find a median now. So to do the median, I'm going to hit second, stat, arrow over to math. This time the median was the fourth one, so I'm going to arrow down until I got number 4 highlighted for the median, hit enter. So just like the mean, I got to tell it where is my list of data at, and that is still in L1. So second, stat, L1 is still highlighted, hit enter. Calculator now says I'm going to find the median of that list one you gave me. So let's hit enter. And that's telling me my median is $1.37. So the middle is going to be $1.37. The mean, the average of them all is going to be 141. So y'all, the stat button to put in your numbers and edit your list. Second stat does everything else. It gets the list and it finds the operations you want to do on it. So if we're doing this by hand, we got to add all these up. So you would come in and add 120, whoops, go back, 109 plus 129 plus 129, 135, 139, 149, 159, and 179. Hit enter, and then divide that by 8, because that's how many scores I had for prices. And look at that, I still get 141. So either way, that calculator can do that problem. And in the median, what I would do to get my median, let's see, my 2 innermost prices were 135 and 139. So I would add them together, get that price, and then divide by 2. So I get $1.37, which is what that calculator gave us. So y'all, the difference is in the calculator, you don't have to put the numbers in order. You can put them in however you got them, and it'll know to order them when it does that median. Okay. And y'all have this recording later to see how I exactly did that mean and median on that thing. Okay. Now the mode, that's not bad. And that's the only one the calculator couldn't do. But you're just looking for which of these values repeated. And there's only one number that repeated up there for us. And that was at $1.29. So since there's 2 values that are $1.29, my mode would be $1.29. All right, so I've gotten a double dose of the mean, median, and mode now, okay? So now we're going to look at symmetry. So y'all, we say a distribution is symmetric if its left half is a mirror image of its right half. So I'm going to show you what it looks like when we have a symmetric distribution. So we're going to have to draw a little graph here. And we're not going to really label this and all that as far as the axes go. We're just going to draw the basic curve that you see when it's symmetric. And y'all probably know this as the bell curve. The bell curve is a symmetric curve. If I'm going to try to draw this, so pretend that's perfectly symmetric. On a symmetric distribution, the mean, median, and mode are all equal, and they're at the peak of the distribution. So the mean equals the median, which equals the mode. They get their height from the mode. Those peaks are always where the mode's going to be because that's the value that happens the most. So that's going to pull up the peak. We get the curvature from both sides having even distributions going through them. So if this was a typical bell curve for a grade in class, the C average is usually where the peak is. You have a few B's and a few D's, and then below you'll have your A's and your F's. The A's and the F's are the least frequent, so they're more at the smaller edges of it, okay? What y'all got to remember for my homework is that when it's symmetric, the mean equals the median, okay? All right, so what happens is they're not always perfectly symmetric. So a distribution that is not symmetric will have values that tend to spread out. On one side more than the other. We call that being skewed. So it skews one way or the other. So it can skew two directions. So first we'll look at a left skewed, and then we'll look at a right skewed. So this is going to be our left skewed. Now what you want to be paying attention to is what's happening with the mean and the median on these, okay? So left skewed, the values are more spread out on the left side. So we're going to draw a little graph of what it looks like to be left skewed. And remember, pay attention to where we place the mean and median. So left skewed is more spread out on the left side. So your little curve's going to come down fairly long on that side, and then this side, it's just going to sort of drop in the end. The peak is still the mode on this. The peak of any distribution is its mode. But y'all, what happens on this is that the median will pull over just a little because you're getting more values at this end. That's going to sort of pull that middle over just a little bit. But our mean, all these extra values, all these outliers are going to pull my mean over even further. Remember, these outliers had a big effect on the mean and not much of an effect on the median and the mode. So they're still going to be sort of tight. It's that mean that's getting pulled over. So for the homework, what you got to know on this, that left skewed, the mean is less than the median, okay? And that's because more values are going to be dotted on that left side. All right, so then we got what? Right skewed. Basically the same thing, except everything's going to shift to that right side. So values are more spread out on the right side. Okay, so we're going to draw our graph for right skewed. So to be the right skewed, your hump will be more toward the left side, your peak, and then this curve is just going to sort of come down and have a lot more values to my right side. My peak is still going to be my mode. This time my median is just going to shift a little bit to the right. So the median still shifting right just a little bit. Because since I had a lot more numbers on this side, I'm not going to be straight in the middle with that mode. And then guess what? A lot more numbers means our averages are being more affected by those outliers. So my mean's going to pull over even more. So what we need to know about this is that the mean is greater than the median if it's right skewed. Right skewed. Oh, that's a hard word for me. So the mean will be greater than the median. So if you notice, if the mean's on the left side, left skewed. If the mean's on the right side, right skewed, okay? All right, let me hold that down and I'll let y'all write that real quick. And then we're just going to talk a little bit about variation. And then I'll show you a couple homework problems where they ask you about the left and right skewed and the symmetry, okay? And then I'll make a little chart that I sort of use for the skewedness part of the homework. So let me flip. So remember, there were 3 cases I showed you. Case 1, symmetric.
Can I see that page again?
Oh yeah, I got you. Let me hold it down. There you go. I probably press hard when I write, makes my paper curl.
Okay.
All right, so You notice we did 3 cases, we drew 3 different graphs. So the main thing you got to realize, symmetric, the mean equals the median. Left skewed, the mean is less than the median. And then right skewed, the mean was greater than the median. So let that be a guide when we do this problem in a little bit, okay? So before I do the problem, I'm going to show you what variation does, because they're going to ask you about variation on them also. So the best way I could describe variation is it's a measure of how far each of them data points is away from my mean. So a while ago, I showed you 3 test scores, and I said it had an average of, I think, 82 or something. So what the variation is looking at, how far was each of them tests away from that 82? Like my 84, that was only 2 units away. 84 minus 82 was 2. My 78 was what, about 4 units away from that 82. So the variation is just looking at all that kind of stuff. And we'll get a little deeper into that next week when we start our 6B, okay? But for right now, all we got to know is what the basic shapes of their graphs will look like. So the variation, it describes how widely data values are spread out about the center of a data set. So the variation we want to know, is most of my data right around that average? Is my data spread out real bad because of that data? Do I have outliers making it a big flat curve? So there'll be 3 shapes on these that we got to look at. So we're going to draw 3 graphs. We'll have low variation, moderate variation, and then high variation. So low variation, it's almost going to look like a little spike coming up. It's going to be narrow and tall because most of your data is right around that median, okay? You don't have a lot of scores spreading you out. Where this moderate is going to be a little shorter than that one and a little fatter. So it might come down a little bit and spread out just a little bit further. But you still don't have what I would call extreme outliers on this one, okay? So notice it's a little shorter than the tall one and a little bit fat because we got more values that are spread out on this one. High variation, that's going to come in, be fairly flat and come back down. Because those outliers and all these data points are being spread out further, you got a lot more variation because not many scores are sitting around that median, okay? So low variation, there's not a lot of outliers at all on this. Most of my scores will be right around what my averages were, okay? So let me show you a question that they ask about that. No, let me find that. All right, so an example of the skewness and the variation. So 100 students took an exam. They found that on this exam, the median test score was 75%. The mean or the average for all these test scores was 75%. The low score was 60, and the high score was 90. So I'm going to compare these to tell what the skewness is. I'll compare this stuff to tell me my variation. So remember, there's three cases. It could be symmetric, left skewed, right skewed. So we got that sitting right there. So look at your mean and median. 75 equals 75. They are equal. Since they're equal, that means this graph would be symmetric. So it's going to be symmetric. And we'll say since the median equals our mean. So then they want to know if my variation low, moderate, or high. Now I will tell you in this homework, the only answers I've seen on them were either low or high. They didn't really have any for moderate because moderate can be almost a judgment call on that one. So they're really going to either hit you with low or high variation. So my scores were from 60 to 90. The middle of it was 75. So I had about 15 this way, 15 to the right for my score being distributed. So y'all, that would be almost like this peak right here. Here's your 60, here's your 90. You don't have extreme scores going to the right, and you definitely don't have any extreme scores going to the left. Actually, our lowest score was a D, our high score was an A. So there's not a whole lot of variation in between there. So we would say that would have low variation. Now, if they'd have said, hey, your low score was a 0, your high score was a 90, then we would definitely have more variation because I would have those outliers out there, okay? So I'm gonna show y'all one more of those kind of problems. So let me let y'all catch up on that a second. Are y'all ready? I'm gonna turn this over so I ain't got flipped up pages. All right, so I'm gonna do another example doing that. And it's the same thing, 100 students this time. So 100 students took an exam. So this one, they found, hey, our median for this was 78. Our average for that test was a 75. We had a low score of 64 and a high score was 98. So first of all, we want to know, is this left or right skewed? So I'm looking at the mean and the median member. This time my mean is less than my median. So remember, we said right here, When the mean was less than the median, we were left skewed. So my mean is less than my median. So we're left skewed. My variation, I'm going to look at these scores right here. So your average is sitting in about a 75. Our range of numbers goes from 64 to 98. So y'all, once again, that's really not a very wide range of numbers. So that would also be what we would call low variation. And think about that. That's a low variation when you consider this was 100 students taking that test, okay? Now, if I'd have had some of these students making 10, 15, 20% grades on it, then I might have stretched that on out to a high variation. All right, y'all, so I'm sort of looking to see, first of it, it's going to start out asking you for those definitions on the mean, median, and mode. You'll have to do a couple where we did the mean, median, and mode, actually find them. And then they'll have a few with graphs, and they'll just want you to reproduce the graphs using the smooth curves. So those aren't bad. I'm trying to find that real quick. So if you notice, they'll have problems where they have a little bar graph like this, and they want you to choose the curve that represents that. So on that one, I went with this B here, because notice if you had a curve, it would come right down that sort of curve, which is what B is doing. A, well, we don't even have a left side coming down like that does. And then C was a straight line going across. So they just want you to pick one of those curves and then tell if it's symmetric, right skewed, or left skewed. Well, y'all, guess what? If that's the mode, the highest value, and most of these values are to the right of that, it had to be right skewed. And then I said fairly low variation because it's only going from what, 0 to 5 on that. So they'll give you a few graphs like that to play with, pick which curve matches it, and then sort of answer a question about it, okay? Remember, right skewed, data to the right, left skewed, data to the left. Symmetric will look like this graph here. This one's symmetric because it has the same thing happening on both sides. It's an image of itself. So I went with C on that because C is a smooth curve. Distributions ain't going to have that kind of a stark peak on it, okay? We always want smooth curves, not the peaks. And I said that was symmetric because both sides are doing the same thing. And then it had high variation. Because y'all, I got scores from way down here, it's around 60, all the way to 120. It covers the whole graph. So I definitely had outliers that were giving me more variation. So y'all, let's see. Let me ask if y'all have any questions on that. It's not a bad homework assignment. I will warn you that next week we'll be finding what we call standard deviations and things like that. Those problems are a little more tedious and take a little more work on us, okay?
Can you put it back on the first page?
First
Came
page,
in
very,
late.
very first page.
Yes.
And I would like to see the last page of notes when you're done with that.
All right, so let me find page 1 here. Da, 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 da. So my page one was this, characterizing data. Then, let's see.
Thank you.
All right, then the last page of my notes, was this the one you're talking about?
Okay, I got that. I thought there was another one.
So after that, let's see. Okay, that was the one I had the 100 students, first one, and then my second one was doing this exam.
Okay, that's what I missed. I was putting dinner in the oven.
Before that was this page.
I got that. Can I see that very, very last one?
Yeah, you should be good then.
Okay, that one.
Yeah. So y'all, you definitely want to be here Tuesday night when I do the standard deviation, because it's one of the trickier things in this class. As far as it's got a long process to it, okay?
What is the hard deadline for having that financing project in?
So the financing project is not too bad to do once you get on it. So I would say Sunday night.
Okay. Thank you.
And now here's the thing. Next week, I'm going to start talking about our second big project, which is a stats project. So y'all look in the email I sent either last night or this morning, I can't remember. But I sent an email with a file for it that's going to tell you how we're going to do our stats project. So the stats project, we'll make a frequency table like y'all did in the homework. We're going to find a mean, median, and mode. And we'll actually do some standard deviations with them. And what's going to happen is you're going to have to find 20 to 25 people to survey. So whatever's convenient to ask 25 people. Or you can ask them.
Any 25 or certain people?
Oh, 20 to 25 will work. So I want
But
you to ask,
anybody, like family?
what now?
Can we do family?
Well, social media, get on Facebook and ask people to respond to a question like, how much do you spend on a phone bill? I had one girl in class say she was going to sit at McDonald's and ask people how much they're spending on their meal.
Okay.
So you just want some kind of data that you can get 20, 25 data values, okay? Call 20 people if you want to, text them, ask them any, and I gave you some example questions on that you can sort of ask. Just get y'all used to doing this. Hell, if you got to, make up 20 numbers, okay?
Okay.
Because we just want to play with this, and this is your second big project, and this is the last one. And then that's why we don't really test on these sections here in the middle, because we do the big financing part project. And we don't test on the stats because we're making y'all do the statistics project. Okay, so just sort of look at that email and I'll walk you through that next week. We'll sort of play the first week trying to get y'all's data, and I'll show y'all things I would do to get data. I mean, today I would probably just hit Facebook up and hopefully 25 friends would respond to some kind of question I'm asking them. You know, just tell them, hey, I'm doing a project for school and I need to ask people, blah, blah, blah. All righty, y'all. So I'm going to stop this share. All right, so I'm going to start grading that what is it, financing my car project this weekend, so probably after this weekend, you'll start seeing scores show up for that, okay? All right, y'all got any questions?
No, sir.
So not seeing no chat, so I'll stop this recording.